Hey everyone, welcome back to creating a simple online game with ct.js and Nakama. In this tutorial, we're going to be taking a look at how to create a game and then join it and then move about, and you can see all the players moving about in the session. So let's first get the Nakama server up and running. So wherever you installed the Nakama server, we can do docker compose up. And this basically sets up everything, and now we have the server running. So now you want to have this terminal somewhere just in the background running. And that's pretty much it for now. So let's put this away. And this is our current example game provided by ct.js, and we're going to be just implementing it, implementing multiplayer into this game, so it's a lot easier to understand. Now the first thing we want to do is create a new script, and we can call this whatever we want, so I'll just call it multiplayer. And this script gets run at the beginning of our game when we launch. So what we actually just want to do, we don't want to go anything fancy right now. We just want to create a session and let players join that session. We don't want any menus to overcomplicate things, so we're just going to create a function which we can call in the browser to create a game and to join a game with a specific ID. Cool, so let's create a function. We'll do this async function creates match. Great, so this function will literally just create a match for us and return an ID, the match ID. And the way we can do that is by simply typing in, we're going to get response from Nakama .sockets .create match. Simple as that. So here we are using the Nakama plugin that we installed. Here we're referencing the socket, which is the thing that connects to the server and always has a connection with. And we're basically just saying create a match. And for us to return the match ID, all we can just do is console.log, match ID, and then plug in the response match ID. Great, so let's test this. Let's launch our game. And as you can see, the ct.nakama has loaded. It will do its thing, finding a session or creating a new session. And so if we just type in here, await create match with a capital M. There you go, we get a match ID. And now this match ID, we can give it to someone else for them to join, and they'll join our session. So let's create a function to join someone else's game. If we go back to our code, we can do async function join match. And it's as simple as typing in that match, so we create a new variable called match, and we say we're going to await for Nakama.socket to join match. And now we need a match ID. And where we're going to get this match ID? Well, we're just going to feed it in here in the function. So whenever we call this function join match, we give it a match ID, and that will let Nakama know which ID to use to join the game. Now this match variable actually contains some quite useful information on what the current match is and all the players in it. But for now, let's just console log the match data structure and see what we get. So now we want to actually get a client to test our joining and creating matches. And the way we can do that is actually by running a little localhost server on the exported files that ct.js makes whenever you run the game. And we can find that directory by, if you go to the hamburger icon on the top left, if you just export for web or desktop, doesn't really matter, it will open up a folder, and if you just go back one and click on exported, this is where you just want to run a localhost server. And the way we can do that is, let's just go and make a new terminal. So for me, this directory is home ct.js exported. So if I just go cd ct.js, and if I go cd.js exported, I am in this directory of home, Alexander, ct.js exported. And now basically here, I'm just going to do if you have Python installed or Node.js, you can easily create a localhost server just to run basically these files in this directory. So for me, that's literally going to be Python m http.server. Here you go. Now we're serving HTTP on this local host. So if I go to this on my browser, if I click this, it's going to open up the actual game inside my browser. And every time I click launch on ct.js, the exported files get updated and I can refresh this browser to get the latest files. Great, so now I have my two clients. I have the ct.js client, which is running on the left-hand side, and then I have the browser on my right-hand side on this localhost address. And as you can see, you know, they are just their own separate clients. We haven't connected anything yet for them to work. Great, so now let's actually connect these two clients together. And we can use the functions that we did to do exactly that. So let's have this left-hand side, the host, and the right-hand side, we can connect that to the host here. So what we have to do is, we can do await create match. Cool, so now we have this match ID. We copy this, and if we go on the right-hand side, and we do await join match, and remember we need to give it the match ID, so I just copied this, paste it here, and there you go. Now I've connected to the match. But of course nothing happens because we haven't told it anything to happen. We've just told it to console log the match presences. We can actually see all the other players in the game, which is referenced here by presences. And it doesn't actually include the actual play itself, but includes everyone else. So we get to see here a list of all the players. And there you go, we have our current host here is listed over here. But that's boring. We want to see the player and we want to see the player move. So how do we spawn the player once they join? Well, the way we can do that is by enabling listeners. And listeners are basically something which is provided by Nakama. Basically says, hey, if someone joins the game, do this. And this, it can be anything that you want in your code. So for us, it's just going to be spawn another player. Now, the way we can do that is if we go to our types, and we're just going to duplicate the player type, and we're just going to call it other players, or other player. Let's actually go into him and just delete everything in his onCreate and onStep and onDraw. So we just want an empty type called another player. Great, so now we have this other new type, and we have these two functions. Now what we actually want to do is have some sort of way to keep track of all the players in our game. And the way we can do that is just simply creating a new variable called connected clients or connected players, and store it as a list or a dictionary of all the players that we have. So I'm just going to go here at the top and just call it connected players. And I'm going to make it a dictionary. And I'll show you why we want it as a dictionary in a little bit. Great. So now that we have the connected players, we want to actually put these connected players inside this dictionary. And now the really cool thing that this match variable contains is, as we saw on the left over here, all of the people currently in the game. And it is referenced here by presences. So what we actually do is we can just loop through match.presences. There you go, dot for each. We call it player. And let's just console log the player, right? Now what this will do is when you join the game, it will list all the players currently in it, not including yourself. But let's save that, let's launch it. Let's create a new game on the host on the left-hand side. Let's copy this. Let's refresh the browser on our right-hand side. And let's join this new game that we just made. Cool, so now we get this object with the session ID, the user ID, and the user username. So now we can use this information to put that in our connected clients or connected players dictionary that we just made, and also spawn the connected people as well. And so we can just use the same loop. So match preferences for each player, and then get rid of this console.log. And we can do connected players. And the way we can create a new value in this dictionary is by just assigning it with this little brackets in JavaScript. We're going to assign it the player.userid. And here we actually want to just assign a ct copy to this key value pair. This way we can easily reference the user ID and their copy inside the game. So let's just create a copy. We do ct.types.copy, and then we want the copy name, which we made earlier, called other player, and we want to give it a x and y value. Let's just default with 0 and 0 for now. So now, if we launch the game, refresh it on our browsers, create a new game on the left, copy the ID, make sure you also include the little dot at the end as that is required. I'm going to join the session on the right hand side. Ta-da! We now get a other player type spawned here on the right. And if we move about, you know, it doesn't actually do anything because we haven't told it to do anything. But success already. We already have another player spawning in our game. Now, you might have noticed on our host, we don't actually see anything happen. Even though there's 2 players connected to the game, we only see 1. Now the reason is because we're only executing this command when another player joins the game. We're not telling the host to listen for anyone joining or leaving the game. And the way we can do that is by using the Nakama socket listeners to basically hear or to catch when someone joins the game and execute some commands when it happens. So the way we're going to do that is we're going to make a new function. Now we're going to call this something like, you know, enable listeners. So in this function, we're going to listen for when somebody joins the game and somebody leaves the game. The way we can do that is by just typing in nakama.socket.onMatchPresence. And we want this to equal a function. I'm just going to player here. And we'll do some arrow brackets, and great. Now this code will get executed whenever somebody joins or leaves our game. And Nakama provides us with a specific variable to see if someone leaves or joins. And it's called this player reference here. So if you call this something else, you know, it'll be whatever you call it. So if player.joins, do something. And for now, we're just going to do console.log, right? We're just going to see, you know, hey, someone has joined. And then we're going to give it, we're going to give it the player that joined. Before we actually launch our game, we need to enable this function. And I'm just going to call it here on create match. And it will now start listening to all of the activities in our game. So let's do that. If we launch the game, we're going to refresh the browser on our right. We're going to create a new match. Now you can see here that we instantly get a message saying, hey, someone has joined. And if we open this up, you actually see that this user is our current user, this host in our game, even though no one else has actually joined. The reason why this happens is because Nakama still recognizes when the host leaves and joins. We can easily fix this in a second, but let's see if it works when someone else joins the game. So if we join this game ID, paste it here. There you go. Hey, someone has joined, and we get to see their username and user ID and all the important information that we need. So now that we can see that someone else joins our game on the host side, we actually want to spawn that other player. And what I'm actually going to do is create another function just called spawn players. And we're going to give it the players variable. And I'm just going to copy, cut and paste this code on line 16 over here. We want to do this so we don't duplicate code in our code base and to have everything in like an origin where we can update it once and it will update everywhere. So I'm going to call this function where I had it before, spawn players. I'm just going to give it, actually here, a quick note. I'm actually going to give it the match presences because we're going to do a loop inside the spawn players in a second. Cool, so we have, when you join the game, you spawn all the players. And also if someone joins, now a quick note again, this actually should be players because it is a list of players that have joined. Even if it's just one player, it still will be a list of just one index or 0. So we check here if any players are joining. If they are, we can then just pass in the players list that we receive. And if we go back to here on our function, we can now loop through every single player and spawn them in. So we can do players dot for each player, do an arrow function, and we can paste it here. Now to check that we are not spawning in ourselves when we join the game on the client, on the host side, we can just do a quick if statement saying if player.user_id does not equal the nakama.session.userid, then you can spawn in the player. Awesome. So now we have this spawn function. Let's save it, launch it, and see what happens. One mistake which I just found is instead of actually giving it players, we give it all the players that have joined. And the way we do that is just by doing .joins. So now if we launch, and if we refresh on the right, if we create a match, copy the match ID, join it on the right hand side, and there you go. Now we get to see both of the clients spawn the player. We get the other player spawned here, and on the right we get the host player spawned here. Now of course this isn't really useful, when I move him out here, nothing happens on the other screen. How do we get to that state? And now here is where the really interesting aspect of Nakama comes in, of sending real-time data really quickly and receiving it as well and updating it on everybody's screens. We want to basically, every time I move my character on to the left, to the right, or up and down, basically send that information to everybody in the game. And the way we can do that is by going to our types. If we go to our player, on step, and this code is basically saying how the player should move, if it hits any collision. We're just going to go right to the bottom, and we're just going to do make a new variable called data, and will be a dictionary. We're going to call it x. Just going to fill it in with the current x and y positions of the player, of the local player that is. So if we do x and if we do y, this.y, and we want to send this data to everybody in the game. And the way we can do that is by doing Nakama. Remember, Nakama is a global class which can be called from anywhere, and socket.sendMatchState. And this function is basically going to call every single time we move and dispatch and broadcast the message to everybody in the connected match of our new position of the x and y value of our current player. Now we don't actually have access to the match ID in this file, so the way we can make it a global variable is by just going to the project. Let's define a match ID over here. It'll be null for now because we don't know the match ID straight away. When we create a match, we are just going to assign match ID to the response match ID. And also when we join a match, we're going to just assign the match ID. Let's actually give this a different name, match ID, to make it a little bit more easier to understand. So we have match ID equals the response ID when we create a match. And when we join a match, we're just going to assign the ID we give it to this global variable that we assign up here. So now if I just copy this, match ID, types, and give it the first parameter, which is the match ID. Now, the second parameter of this function is the opcode, and I see the opcode as basically an operational code to say exactly what we're doing. So 1 could mean we are moving the player, 2 could mean we are going to be jumping the player, 3 could mean we are killing the player, or something along the lines of different codes to represent different things that the player is doing. For now, we're just going to stick with 1 to just represent, we can even comment it here saying
opcode 1 equals moving the player. Okay.
So we give it the match ID, we give it the opcode, and the opcode, we're going to actually talk about this a little bit more in detail in a little bit. Now we want to give the data, and because we already defined the data above it, we're just going to send data. And what this, like I said, what this is going to do, every single time we move, it's just going to keep on sending our X and Y positions to everybody. This way we can now hop onto our script over here, and we're going to use one of the other Nakama listeners called Nakama. Nakama.socket on match data, and we're gonna do this. Call the data. Great. And now what this function is going to do is going to listen to all of the messages we send. So we have a client here, and this client's saying, "Hey, I'm moving, I'm moving, I'm moving." Everybody else is going to receive that data through this function on match data. So whenever data is sent, this code will be executed in our game. And this is where kind of the power of opcodes come in hand. When you have a big multiplayer game, you can really define and fine-tune what gets done by doing the different opcodes. So 1 is movement, 2 is jumping, whatever. And the way we do that is by just having a switch case, which we will define by data.opcode. And I'd just like to say that all of this information is on the Nakama documentation for JavaScript. So if you get stuck anywhere, or if you have any more questions, or you want to get into more detail, there's a lot of information on there as well. So we're going to switch on the opcode. I basically want to say, if the opcode is 1, do this. And we're just going to do a break for now. Also going to have a default one that says, we're just going to console.log, invalid opcode. So basically, switch case goes here, and whatever this value is. So in our case, it's going to be 1. Do here, come over here and do whatever we say. If this is like 10, it's not going to find any case, and it's going to go to the default one, and it's going to print out saying, we can't find your opcode. Sorry. So now that we have data coming in every single time we move our player, we need to tell all of the other players, all of the other clients, to update their position on our screens. And the way we can do that is by basically updating the X and Y value of their type. And I'm going to create a new function now called move player. Now this is a singular player. So we're going to give it, we're actually going to give it the user ID, and we want the new data that we are going to be updating this player with. So we're just going to call it, let's just call it player data. Now in our switch case, we want to call this function. So move player. We want to give it the user ID, which we have in this data value. And we can access it by going to data.presence singular, which is basically the player who's sending this information, and that comes with the user ID that we need. The next thing is we want the data they're sending, and that is actually stored in data.data. Now data.data is a bit weird, so I'm just going to rename this data to result. I'm going to rename this to result as well, result and result. So a client sends their position, with an opcode of 1. Now on our clients, we receive this new data. We see it's with an opcode of 1. Then we call the function movePlayer with the ID and with the new data of that new player. But we're not actually doing anything in the player. So what we're going to do is we're going to access the connected player in our local variable. And because we assign the player ID whenever we created a player as the key, we can easily access the value of that key pair value by just typing in user ID. And now we have access to the player on our local machine, right? And we can do whatever we want with it. And in this case, we just want to update the position. So if we just do .x, and the .x comes from the ct.types copy, every copy has an x and y value and a whole bunch of other functions we can mess around with later. But for now, we just want to use the x value. So we do connected players user ID. We find the player by their user ID. We get their x value. And we're going to update that x value by just typing in player data.x. Ta-da! It's that simple. And we're just going to copy this line and we are going to paste it below, change the x to the y value, save it, and hopefully we should be able to see our characters moving together. So let's create a match. Let's copy the match ID. Let's refresh the browser on our right hand side. Let's refresh again. There you go. We're going to join the new game match that we created. Okay. And there you go. On our left hand side, we actually get to see the our character moving. Now on the right hand side, I'm not sure what's going on. We'll debug that in a second. But it works. Of course, the animation doesn't work because we haven't told it to do any animation. But you know, if I jump on the right hand side, it jumps on the left hand side. So that's amazing. It's that simple just to create an online game. And we're not done yet because we have this bug of the other player not moving on the browser. So the reason why we have this bug in our browser is because we don't enable the listeners on the browser. We enable the listeners only on the create match, and we only create the match on the left hand side. So the way we can just easily fix that is whenever we join a match, just enable the listeners there as well. So if you do Control S, we launch, and if we refresh on the right hand side as well to get the updated files, create a match, we copy the match ID, I'm just going to refresh again, join, paste that in. I think it's working. There you go, awesome. And if I move on the right hand side, I'm on left on the host, the other player gets to see me moving as well. We have managed to create a really easy way of moving our players about on 2 different machines. Now theoretically, you can send this to your friends and it'll work, but we're not done yet. We want animations to play, we want, as you can see, collision doesn't work yet with everyone, it's not global, so over here you can see that I'm kind of colliding inside here, but on here it's moving things. So it's still a little bit buggy, and there's a question of how are coins going to work, are they the shared state, are they not shared states? We can all get to that in the future video. Awesome, so that was it for this tutorial. If you have any questions, do let me know in the comments or on the GitHub or on Discord as well, on ct.js Discord. I'm happy to answer any questions you may have, and I will hopefully catch you in the next tutorial where we do collisions and animations. Cool, thanks for watching.